Hello, today we're going to have a discussion on volcanism and extrusive rocks. When we're talking about volcanoes and how rocks are formed from volcanoes, there's two kinds of rocks. There's extrusive and intrusive. We'll talk about intrusive as well, but extrusive means that these are the rocks that are formed on the Earth's surface, not deep within the Earth. And they form specific kinds of rocks. So today, as we talk about the origins and how volcanoes work, I've got some really great videos that you'll see active volcanoes erupting and things like that. So we'll have some fun with this. So here's just a short one. This guy is a scientist. He's called a volcanologist. I'll just let this play in the background for a second. You can see him there on the bottom. A little braver than I am, but he's literally down in the throat of an active volcano. And he's known for this. He likes to visit these kinds of things, and he's well known for his work with volcanoes. So I have seen an active volcano just once in my life. I went to Nicaragua a couple of years ago with a group of students, and we were able to drive up to the top of an active volcano. It took us several hours to wait our turn to get to the top. And once we got to the top, it was dark, and they only let us stay there for about 5 minutes because there were so many people wanting to see the active volcano. It had just barely become active just in the last few weeks when we got there. And I remember very specifically, we parked in a parking lot after driving up to the top of this mountain that took us about an hour. And then we all got out and we walked over to the edge of the caldera, and they had a little tiny rock wall there to not go any farther. It was only about 3 feet tall, but I remember looking down over that rock wall, and you could see down. It was probably more than, I would say it was nearly 800 feet down, and you could see the volcano down below. You could see active lava just moving extremely fast, like a river of hot molten lava. And I remember putting my hand out just over, and it was hot enough that if I had a hot dog on a stick, I think I could have roasted the hot dog from the heat that was coming off of it. They only let us stay there for just a few minutes, and the darkness made it amazing, and we got some pictures, and there were no lights up there at all, no city lights, no street lights. And it was truly amazing. And then we drove down the mountain. So I want to talk for a minute about how volcanism plays a role in basically all of Earth's spheres. The first one, of course, is the atmosphere. The gases that we have in the atmosphere, the original gases, the carbon dioxide and so forth, may have been first introduced into the Earth's atmosphere through volcanic action. And not just that, but when there is a volcanic eruption, particularly a big one, it can change the entire layout of Earth's atmosphere for a period of time, coating the Earth with ash and dust, which can block sunlight and cause a cooling effect. We know that this has happened before, and this effect probably led to the destruction of the dinosaurs, but even more recently, back in the early 1800s, the people living in the eastern United States experienced what they called the small or tiny ice age, and it truly did snow in July. They lost their crops because of a volcano that erupted, caused the whole planet to cool down several degrees, and it killed off their crops. And that particular year of the little ice age, people died from starvation because the failure of crops in July. The hydrosphere, of course, is affected when volcanoes erupt. They release a lot of water vapor that's trapped in the earth, which provides water vapor into the atmosphere. And then, of course, the biosphere, this is the life part of the earth, can be negatively or positively influenced. So for instance, in the case of where people live, people have tended to live on the slopes of volcanoes for centuries because the soil is very fertile. It's very high in minerals, and so vineyards and wineries and other places on the earth, they grow crops on the bases of volcanoes because they're so good as far as the soil goes. But of course, if you live close to an active volcano at any one time, the volcano can also kill you. So this is the Ring of Fire. You can see mainly in the area between the United States there and Australia, you'll see the Ring of Fire. This area here is on tectonic plates, and so it's where we see a lot of active volcanoes. And truly there are a lot of them. And the reason why, again, is because it's on the edges or the boundaries of plates, Earth's tectonic plates. Lava is the name we give to liquid rock that is on the Earth's surface. Magma is the name we give to liquid rock that's deep in the ground. So lava is on the surface, magma is in the ground. Lava flows can happen at any volcano. Some volcanoes are more explosive than others that we'll talk about, and others are they're not that explosive and not terribly dangerous as long as you keep your distance. So this is in Hawaii. As you can see, these are lava flows. There's parts of the Hawaiian volcanoes that are active all the time. They're constantly releasing lava, which means it's making new ground. It's literally producing new ground, and the island is getting larger over time. So I want to go through a little bit of some of the volcanoes that are currently active and talk a little about their history, or those that had been active not too long ago. There's a lot of volcanic myths and religion and mythology associated with it. Hawaii, of course, the god Pele, and Iceland is Loki. The people that used to live in these areas, or still do, have a lot of history and mythology associated with that. So we'll go ahead and talk about a few of these now. Pompeii, of course, is one of the most interesting ones to talk about. This is Mount Vesuvius. Mount Vesuvius here was active in 79 AD. And the people that lived in the city nearby, you can see how close their city was to the volcano. It decided to become active literally overnight, and it killed somewhere on the order of around 20,000 people. And it's now a museum that you can visit, and here you can see some of the bodies of the people that literally laid down and died in their sleep. The ash that came down choked them, and it encased their body in an ash. And when they excavated this, they found thousands of bodies of people laying down, some of them holding their children. Very sad, but this all happened literally in one night when this volcano became active. This is Mount, I don't know how to say it, it's Pili, I guess. A town called St. Pierre was completely destroyed by the volcano becoming active. And then a more modern one in 1984, the Mayon volcano in the Philippines. Erupted. It was a big eruption, and then Mount Pinatubo erupted later after that. So very active places. Again, this is in Hawaii. You can see places where the lava covered roads, and more recently, just a few years ago, when they had a big new active part of the volcano, it destroyed some houses and subdivisions. So it's just the price that you pay when you live on or near an active volcano. So here's a video of a volcano erupting.
Watch out for the shock, it's coming.
See the shockwave that hit those people. That was quite a big one. Here's another one. This is called the pyroclastic flow. This happened in Japan back in 2014, and this one's actually kind of sad. There's people down in that canyon on hiking trails, and unfortunately this volcano released a burst of hot ash and dust, and it traveled down through the canyon and killed them all. I think over 30 people lost their lives here. So here you can see the hot ash traveling sometimes more than 200 miles an hour down into the valley, reaching temperatures of over 700-800 degrees, literally baking the people down in there. It's very sad, but this happens when we have active volcanoes. So again, that's called a pyroclastic flow. Pyro means fire, clastic means chunks. So it's basically chunks of hot, fiery rocks, ash, and dust traveling down the canyon, and it was a pretty big one. Here's another active volcano. show the same one again from the side, a different angle. Amazing to see the awesome power. So in volcanoes, what makes them explosive or not explosive has to do with three main things. One is the amount of dissolved gases in the actual lava. The other one is its temperature. And then the other one is the silica content or the viscosity. So you can get situations where you have trapped gases, lower temperatures, and high silica content, which makes the lava more thick. And more thick lava tends to be more explosive because it can trap those gases more easily. Yet on the other hand, other lavas that are very, very hot, very low in silica, tend to be not explosive at all. The volcanoes of Hawaii are not that explosive. They're made of high viscosity, high temperature lavas that are more runny, sort of like diarrhea than anything else, and they are not that explosive. Whereas other volcanoes, like the ones in the Philippines, the ones on the western coast of the United States, like Mount Shasta, Mount St. Helens, these tend to be very explosive lavas. And so when they do explode, they tend to be much more catastrophic. When we divide extrusive rocks into groups, the best way to do that is, are they light or are they dark or are they somewhere in the middle? And so we look at their colors first. Light colored rocks are high in silica. Now, silica is quartz, okay? So if a rock has a lot of quartz in it, or silica, they tend to be very light in color. Rocks that are very dark in color will have little or no silica at all. So please remember that. I'm going to say it again. Quartz or silica is a light colored mineral. And if rocks are high in quartz, they'll be light in color, such as rhyolite. If they're dark in color, that means they have little or no silica in it, such as basalt. And then you can get in between, where you have sort of half and half, and those are called intermediates, such as andesite. Then we look at their textures. Some volcanic extrusive rocks are glassy in appearance, such as the obsidian you see here at the top. Some are fine-grained, and some are very coarse-grained or porphyritic. Here you can see on the bottom, the picture there, you can see the little crystals within the rock. The rule of thumb is this: if an igneous rock has very large crystals, that means that it cooled deep under the ground, such as granite. If it has very tiny crystals or no crystals at all, that means it cooled at the Earth's surface very quickly. If you look at that piece of obsidian right there, it looks like volcanic glass. It cooled so quickly that it literally, the lava was dripped into water like the ocean, causing it to cool almost instantly. Some rocks, because they have a lot of trapped gases in it, when they cool, they formed rocks that can literally float on water, such as pumice. And the word vesicular or frothy simply means it has lots of holes in it. You've probably heard of pumice or scoria, which are other rocks that are full of holes, and they're light. These are called volcanic bombs. Notice their shapes. This means that they were shot out of a volcano as liquid, and then as they were traveling through the air, they sort of extruded out into these lens-like things. They're often called teardrops, and then they cool before they hit the ground, forming these really interesting bomb-like structures. There are three kinds of volcanoes. The first one is called a shield volcano. Shield volcanoes have gentle slopes between 2 and 10 degrees, so think of it as like this. And then a composite volcano has slopes that are usually greater than 10 degrees but less than 33. And then you have cinder cones which are greater than 33. So again, if you go to Hawaii, Hawaii is a shield volcano. People live on the shield volcano. It's very shallow angle. On the other hand, if you look at a volcano like Mount Shasta or Mount St. Helens, it has steep angles. And then around here, we actually have some cinder cones, which are usually much smaller, but have very, very steep sides. So let's take a look at some examples. This is a simple drawing of a volcano, kind of looking at it from the side. Of course, you'll have the main vent, which the lava and ash and gases will escape from. Sometimes they'll shoot out side vents, as you can see here. The crater is at the top. And notice that it forms layers, because if a volcano erupts over many different times, mainly even centuries apart. It'll form these layered layers as it comes down the side. The vent of the volcano, of course, is where the lava comes out. Sometimes those the tops of the volcanoes, after the eruption, the crater collapses and it forms a caldera. And you can see a caldera here in the picture at the bottom. That is Crater Lake in Oregon, where the old mountain called Mount Mazama, after the eruption, it collapsed and then filled with water to form the beautiful Crater Lake. So here's a vent here at the bottom. You can see it smoking. It hasn't erupted for a while, but it's still somewhat active. And here's a shield volcano. Basically, we're looking at Hawaii. Again, shallow angle and not explosive. These are some old cinder cones you can see here in the distance. Those are just old cinder cones. And then there's some around us. So this is over by Sigurd. And now, it's not the hill in the back that looks like a volcano. It's actually the black mound in the green field. This is the cinder cone. And you can see this if you drive on your way to Aurora. So what happened is the volcano nearby, lava came up through the ground and extruded lava through a cinder cone right out in the middle of what is now a field. There are several of these around. We usually go on a field trip down to some cinder cones down by St. George. And this is one of my former students, and he made this very funny, so I'll let you see this.
Going. Cinder cone! Wait. Cinder cone!
I love that. This is down by Diamond Fork, or down there by Snow Canyon in St. George. Those are actual cinder cones there. Here's Sunset Crater, which is a cinder cone in Arizona. I've been to this cinder cone. It's by Flagstaff. It's very interesting. And then here is some lava coming out of a basalt volcano in Hawaii. So this is just showing some of the active volcanoes in Hawaii. This is Kilauea. It's constantly active in places, and it changes quite often, but as I said, the volcano is literally making new island every single day as new lava is extruded onto the Earth's surface. As long as you don't get too close, you can watch this live. You can sit and see it happen, and it's very interesting. I've actually not been to Hawaii, so I guess it's on my bucket list of things to do. So this is called a little spatter cone. It's just a little tiny active cinder cone. This is not a video, but you can see that it would normally be very active. Here's a scientist. They're called volcanologists. They study the lava coming out of these cinder cones or out of the volcanoes, because by taking samples of the melted rock and then cooling it and looking at the composition of it, they can actually do some kinds of prediction where they can determine the content of the gases in the volcano to see if there might be other chance that it could become more active in the future. This is called a volcanic window, where you're looking down into a volcanic tube where you can see a river of lava. They will dip down in there and get samples of it and cool it in water, and then take it to a laboratory to see what the composition of that rock is. This is an old lava tube. Maybe you've been in some. There's many throughout Utah. There's some up above Cedar City, Mammoth Caves, and then there's several down in Snow Canyon by St. George, and I've been in all of them. They're fun to walk through, but you can just see that hot molten lava traveled through this like a river, carving down through here. So let's go ahead and talk a little bit about, again, we've talked a little bit about the types of volcanoes and the way that they form. So a composite volcano is going to have steep sides. They're going to be very explosive, and that's because the viscosity of the magma, or of the lava coming out of it, causes the angle of the volcano to have steeper sides. So that's typical in this case. This is Mount Shasta. Mount Shasta hasn't erupted for some time, but that doesn't mean a thing. It can erupt again. They obviously monitor these mountains very closely to make sure, but in this case you can see the older lava flows that have happened in the past. This is a volcanic dome. This is a volcanic dome of Mount St. Helens, which erupted when I was in high school. The dome there in the center is what's left over, so it's sort of like the plug that fills the vent. After the eruption, it fills with this vent, with this plug, and they monitor this plug very, very carefully, because if it starts to grow, it could be a sign that the volcano is becoming active again and could erupt again. There's evidence in areas throughout, particularly this one is up in Washington State and some of Oregon, of literally volcanoes that erupted for millions of years nonstop, completely raising the entire area several thousand feet, and changing the Earth's climate dramatically. So this is an example. These are columnar joints. This is, in some cases, when lava cools, it forms these little six-sided columns. We have some of these right up on I-70 by the Indian Museum up there. There's these columnar jointed basalts when they cool. This is called pillow lava. When lava erupts under the water in the ocean, when it cools, it forms these unique structures called pillow lava. And here's a very short video of this happening. So again, this is underwater. So as you can see, as it comes out, it cools and crusts over very quickly on the surface. And then it's interesting, when these things are seen at the surface of the Earth, they look like this. This is actually ancient pillow basalts. You can see the unique structures that they form. And then lastly, it's fun to talk a little bit about volcanoes on other planets. The largest volcano in the entire solar system is on Mars. It's called Olympus Mons, and there's a picture of it there at the top. This volcano is so large that it's over 600 miles across, and you would have to walk 300 miles just to get to the top. And the top of it is so high, it's over 16 miles high. To put that into perspective, Mount Everest, the tallest mountain on the Earth, is around 5.5 miles high, and this volcano on Mars is 16 miles high, 3 times higher than Mount Everest. If this volcano was, if this volcano was on the Earth, you would have to wear a spacesuit to go to the top. It's no longer active, of course. It's been very silent for millions and millions of years, but we know that Mars once had extremely active volcanism. And then there's a little moon around Jupiter called Io. It is the most volcanically active body in the solar system. This little moon, Io, is so active that the entire surface of the little moon completely recoats itself with new lava every few years, because it has hundreds, if not thousands, of active volcanoes on its surface. We also have evidence of volcanism on the moon, even though, again, there's no longer any live activity. When you look up at the moon at night, what some people call the man in the moon, the dark areas on the moon are great big basalt lava flows. In the moon's ancient history, the surface there that faces the Earth would have had very, very large flood eruptions of basalt onto the surface. Again, this is a picture of Olympus Mons on Mars, larger than the state of Texas. And then here's the moon Io around Jupiter, and the picture there shows an active volcano where it's so violent that it's actually shooting stuff off the surface of the moon into space. Okay, that ends this brief overview of volcanism and extrusive igneous rocks.